Continuing on with question number 2, we have a figure drawn like this, a square subdivided into multiple other sections. And they're asking us to find the proportion of the big square that's shaded. So this lower left corner, that lower right of the inner square, this top one of the inner square, that proportion of the total square that's shaded. Right? So we want to think in terms of what we can utilize in terms of symmetric shapes. Right? What I did is I said, since we're looking for a proportion of the entire square that's shaded, just said let's start off by calling the area of the entire square one square unit. Might as well call it something, we have to name it, so 1 square unit. If we subdivide this first, we're looking for this big triangle here. That big triangle is represented by this lower corner right down here, and I've simplified this expression a little bit over here, right? I've taken out all the subdivisions of this middle thing. Because we want to recognize we're looking for this area, this lower triangle, and right now if we subdivide it this way, you can see that we have 8 different triangles, all of which are equal in area due to symmetry, right? So we've got 1, 2, 3, 4 on the bottom, 4 more on top, 8 total triangles. This is one of these 8 triangles. This lower left shaded portion is this piece right down here. All right, so our area up here of this one, I'm just going to label it as A. That is 1 part out of 8. So we have that. We need to do this one here. We need to do that one there. I'm going to go ahead and write down an A sub 1 in this one. A sub 1 is 1/8. We're going to have to add to that area of the top triangle and then the area of the smaller triangle here. That top triangle, it's inside this square that's been rotated 45 degrees. That's the purple one over here, which I redrew down here. And if we repeat the process of finding the symmetric triangles that are inside it, we can see is that all we did is we took this and we rotated it 45 degrees that way. We have the same 8 triangles here that are all equal in size because they're just doing the diagonals of squares and we got symmetry. So we're looking for this top part there, which would be one of the 8 equal triangles in this one. Right? So we're doing 1/8 of this and this purple square. That purple square area was actually composed of the 4 triangles out of the 8 that we had when we initially subdivided this. We took this, divided it up into 8 triangles, 4 of which become the area of this triangle or this square right here on the inside. Right, that big square that goes down this way, it is composed of these 4 triangles out of the initial 8. So 4/8, we can reduce it to 1/2, to 1/2. So the area of this purple square is 1/2. We are looking for that right there, which is 1/8 of the 1/2. Right? So this area right here, which I will call A2, equals 1 part out of 8 of our square. And our square is 1/2 as large as the original. The original one had an area of 1. So this purple square has an area of 1/2. We're doing 1/8 of it, which is 1/16. As for the square that's on the inside, this one right here, which I have used red for, that one has a total area of 1/2 of this purple area. Purple area was 1/2 of the big black area. I probably should have drawn it as purple here and red here. I didn't, probably should have. We have this, we're doing 1 part out of an equal 8 on this too. I hope you can see it. I'm going to stare at the screen. You can kind of see that. We're doing the 1 lower right corner right there. Lower right corner of this one. So the lower right corner of that one is 1 part out of an equal 8 parts, or 1/8 of the total area of the red square. That red square is 1/4. So we're doing A sub 3, This pen's not writing. That would be 1 part out of 8 of the area of the red square. Area of the red square was 1/4. So we get a 1/32 for it. The total shaded area would be those 3 added together. So you just look for the subdivisions that give you nice symmetric shapes, geometric shapes that we have formulas for areas of, and go from there. Area 1 was 1/8. Area 2 was somewhere over there, 1/16. Area 3 was down here, 1/32. And now we come to what's going to be the nemesis of a lot of your K through 8 students, adding fractions. The way we add fractions, no doubt you all will remember this because you've already done it. Get a common denominator, preferably a least common denominator. For these, it's pretty easy to see it's going to be a 32. I'm going to write what we have up here in black. Leave a blank space. Leave another blank space. There are lots of special numbers in math. 2 of them that are really, really, really special are the numbers 0 and 1. 1 is special because it's called the multiplicative identity. It means when you multiply by the number 1, it does not change the value that you started off with. And it's weird how often in math you multiply by the number 1 and never even think about doing it, but it's done so often. When we get the common denominator here of 32, we want to write all these as some fraction over 32. That one is done, right? This one we need to multiply by the number 1 in such a way that it puts a 32 on the bottom. 8 times 4 is 32, so we multiply by a 4 on the bottom and on top. 4 divided by 4 equals 1, so we're just multiplying by 1. It will not change the value. It's still going to be 1/8. 16 times 2 is 32, so we repeat the process. We multiply the entire fraction by 1 in the form of 2/2. And again, the 1/32, it's already done. It's over 32, so we're fine with it. So if we do this, we get 4/32 plus 2/32, which is our original 1/16, plus 1/32. We're adding 4 things and 2 things and 1 more thing. Those things are all 1/32 of our big thing, our big square. If we subdivided them into rectangles the size of that one there, we'd have 32 of those rectangles. We'd have 8 of them in this little one. We'd have the ones on the outside, and I'll let you do the drawings and grab a ruler and do it if you wish, but we'd have 32 total. 4 of them, 2 more, 1 more gives us 7 of them out of 32. And that's what we would get if we if we added up all those areas of all of our little triangles. So for that one, 7/32, hopefully is down there somewhere. It ought to be. That is answer number A. So that is number 2.